Hello students, in this video I am going to go over an exercise on writing quadratic equations if given a set of conditions. So let's take a look. Okay, my first example is I'm given the information involving a vertex and a directrix, and then just from this alone I have to come up with the quadratic equation. So just a reminder, okay, of some of the things that we'll need for the assignment. Okay, it's this information here. This was the information that I had gone through in previous videos. It is really important that you try to understand an equation and not try to memorize the equation. You should always try to understand the equation and try to pair it with a diagram. Good math teachers will always tell you this in the future, that in order for you to truly understand an equation, you also have to understand the picture that comes with it. So analyze the equation, analyze and scrutinize over the diagram. Okay? All right, so let's take a look. So in this exercise, you're given the vertex. I always think it's a good idea to draw out the situation. So when you draw, this is also a skill. You don't ever have to draw anything to scale. I mean, you can certainly do that, okay, but it's a lot of wasted time when you're just trying to get a ballpark of where everything is. So the vertex here is 7, 4. I have the directrix as y equal to 6. And just immediately looking at this, I already know how the parabola is going to be oriented. From my understanding, the directrix and the parabola will never intersect. Because they never intersect, the only way that we can draw this parabola is by having the parabola be upside down. So just from the mathematics alone, if you do everything correctly, okay, we should come up with a leading coefficient that is negative. So let's see if the mathematics itself will actually get us there. So I am aware that the distance between the directrix and the vertex, that is assigned a variable that is given by the letter p, and I know, because I have a vertex here, 7, 4, that it would be wise for me to express the equation of the quadratic equation in vertex form. So therefore, a times x minus 7 quantity squared plus 4. Now I do have a relationship for a and for p, and that is a is equal to 1 over 4p, where p again is the distance between the directrix and the vertex. So again, the mathematics itself should tell us, okay, whether or not this is going to be upside down or right side up. Now that I know this, okay, I can see that p here is equal to 2. And since p is equal to 2 and y is equal to 6, right, I actually know, since y is equal to 6, I know that 6 is equal to k minus p. And if k is equal to, if 6 is equal to k minus p, then I know that k in this case is 4, right? So therefore I can say 6 is equal to 4 minus p. So therefore p would have to equal to negative 2. Why did I go through this big trouble of figuring out p this way when we could have, just did what I did 30 seconds ago and pointed out that 6 is just 2 away from 4? Well, that's because I wanted to show you that the mathematics will reveal what the sign of a is. And if I put this in, you're going to see that a is equal to negative 1/8. And that is again going to reveal that this is going to be an upside down parabola. So the equation is y is equal to negative 1/8 x minus 7 quantity squared plus 4. That's the solution right there. And again, I didn't have to know that the parabola was upside down. The mathematics itself is sufficient in telling us that. Let's take a look at the second question. So I know in this example here, you're told the roots. So just immediately I recognize that maybe perhaps it would be convenient for us to express this in factored form. So I know that y is equal to a times x minus r1, so it's minus negative 4, times x minus 0 Or when expressed, again, a is the same as before, right? A is equal to 1 over 4p. And this is really x plus 4 times x. So let's try to draw the situation. So I know that the roots, one of the roots is at 0, another is at -4. Now, a lot of information is actually expressed in just those two pieces of information. What other information is given to us other than the roots, you may be wondering? Well, I know that this has to be an upside-down parabola because the directrix here is above here. And knowing that the parabola and the directrix can never ever intersect, that is the only way that I can draw this. What kind of other information is actually implicitly being told to us? Well, because we know the roots, we also know where the axis of symmetry is going to be. Because we know where the axis of symmetry is supposed to be, right? We then know one of the coordinates of the vertex. So how do we find this out? Because I know the roots and the axis of symmetry is going to be exactly in the middle of the roots, I immediately know that the h-coordinate, the x-coordinate of the vertex, must therefore equal to -2. And I don't know what k is, right? K being the y-coordinate of the vertex. I don't know what that is. But I do know, okay, if I substitute in -2 into this equation here, what would happen? I'll end up with the y-coordinate k. So that's what I'm going to do. I want to set that equal to k. So if I substitute in the x-coordinate of the vertex, I'm going to get back k. So it's -2 plus 4 times -2. And if I perform the simplification, I'll end up with k is equal to -4 over 4p, or -1 over p. If k is equal to -1 over p, and I know that the directrix is equal to 2, and I also know that the directrix can be found by doing k minus p, so therefore I can perform a series of substitution there. I can say that k is equal to 1 over -p. I want to make that substitution. So this is -1 over p minus p. And this is the directrix, right? So therefore this is equal to 2. I now have an equation with one unknown, so that I can solve for what p is. So if I do this, I'll end up with 2 is equal to, or 2p is equal to -1 minus p squared. I want to add p squared to both sides. I'll end up with p squared plus 2p plus 1 is equal to 0. Now I can solve for what p is. P is, at the end here, this thing is factorable. P plus 1 times p plus 1 is equal to 0, so therefore p must equal to -1. So because p is equal to -1, I have everything. The equation, therefore, is equal to y is equal to 1 over 4p, right? So it's -1/4 x plus 4 times x. This is the solution. Let's take a look at question 3. The focus is 3, -1. The directrix is y equal to 4. Again, I'm going to draw the situation. Whoops. So the situation looks like this. 3, -1. So I am looking at a point that's over here. I'm going to call that 3, -1. And then y equal to 4 is the directrix, is somewhere up above. Okay. Now, in order for me to draw this, okay, I am once again going to be dealing with an upside-down parabola. Okay. Now, the distance between the focus, which is 3, -1, and the directrix, which is y equal to 4, this is a distance of how many p's? This is a distance of 2 p's. because this is a distance of 2 p's, okay, and I know the distance between y equal to 4 and 3 comma negative 1, this is also a distance of 5, right? This has a distance of 5. So therefore I can say 2p is equal to 5, or p is equal to 5 halves. Because I know it's an upside down parabola, this should be a negative 5 halves. How do I know it's an upside down parabola again? Well, that's because this is the only way that we can draw this, right? If we have the parabola going in the other direction, p would have to be, well, if we have it going in the other direction, then the parabola and the directrix would intersect. So because of this, okay, I also know what the vertex is going to be. The vertex is going to be h comma k, right? So the vertex is going to have the same x-coordinate as my focus. It's going to be 3. The y-coordinate of the vertex, well, I know that the focus is, the y-coordinate of the focus is negative 1. Now, the y-coordinate of the focus is always going to be k plus p. Since p is equal to negative 5 halves, since p is equal to negative 5 halves, then I know that negative 1 is equal to k minus 5 halves, or plus negative 5 halves. So therefore I'm going to add 5 halves to both sides, so therefore k is equal to positive 3 halves. So this is going to be positive 3 halves. So now that I know what the vertex is 3 comma 3 halves, and I know what p is equal to negative 5 halves, the equation is going to be 1 over 4 times negative 5 halves times x minus 3 squared plus 3 halves. Or in other words, y is equal to negative 1/10. No, yes, it's negative 1/10. What am I saying? It's negative 1/10 x minus 3 quantity squared plus 3 halves. All right, next I have focus and a vertex. So the focus here is, let's draw this situation out. So I have 7 comma 2, whoops, and 7 comma negative 3. So 7 comma 2 and a 7 comma negative 3. This is the focus and that's the vertex. So this is the focus and this is the vertex. So the only way that we can draw this is by doing this. It's a right side of parabola. The distance between the focus and the vertex must be positive. The value of p. And in this case here, I know that p therefore has to be a positive value. So what is that distance? Well, that's just 2 minus negative 3 then, right? So p is equal to 2 minus negative 3, or is equal to 5. So if p is equal to 5, I know that a, therefore, is equal to 1 over 4p. So this is going to be 1 over 20. The equation will turn into y is equal to 1 over 20, x minus 7 minus 3, x minus 7 squared. And that's the equation for number 4. Last one. I have root 1 and root 2. So again, this is 2 and negative 3. So I have a situation like this where this is 2 and this is negative 3. And passing through 0, 1. So it's going to be right here. So the only way that we can actually draw this is by doing this. And the best way that we can go about this is, since I know I have the roots, I can just immediately substitute this in. X minus 2, x plus 3. I'm going to substitute in 0, 1 in. So if I do that, I'll end up with 1 is equal to a times 0 minus 2 times 0 plus 3. So I'll end up with 1 is equal to a times negative 6, or a is equal to negative 1/6. So the equation is negative 1/6 x minus 2 times x plus 3.